Good morning, everyone. This is Shashmita. Welcome to Science Warrior YouTube channel. If you want to learn science in simplest and easiest way, then subscribe my YouTube channel and hit the bell icon. So today we are going to learn the new topic. Let's start the video. So today we are going to learn the new topic whose name is exploring forces. So the first question arises here, what is force? A force is a push or pull acting on an object. Forces are all around us. They can start motion, stop motion, change the direction of motion, or even change the shape of an object. So if we push something or pull towards ourselves, let's take an example of our classroom wall or our room wall. If we push it and if we pull the door towards ourselves, then what happened? We exert a force on them. We hit a cricket ball, then it changed the direction of motion. So what is push? Applying force away from body. What is pull? Applying force towards our body. Forces can change speed, direction and shape of object. Effects of force. That is three effects. There are three effects. Change in motion, change in shape, change in direction. What is change in motion? A force can start a stationary object moving, stop a moving object, or speed it up or slow it down. Example, kicking a ball set, it is in motion. When we kicking a ball set, it moving backward and forward direction. So it changes motion. Change in shape. Forces can deform objects by stretching, compressing or bending them. Example, squeezing a rubber ball or compressing a spring changes its shape. When we compress a spring, it smaller in size. When we release them, it changes to normal size. Change in direction. A force can alter the direction in which an object is moving without necessarily changing its speed. Example, a cricket bat deflecting a ball changes its direction of motion. Types of forces. Forces are broadly classified into two main types based on whether physical contact is required between objects. Understanding these types helps us explain how everyday interaction and natural phenomena work. Contact forces and non-contact forces. What is contact forces? The contact forces require physical touching between objects to act. Example, muscular force, friction, normal force, tension. What is non-contact forces? That is, forces act over a distance without touching. Example, gravitational force, magnetic force, electrostatic force. The examples of contact force are pushing a box, friction while walking, a stretched rubber band, normal force on a table. The example of non-contact force, that is earth gravity pulling objects down, magnets attracting iron, charged objects repelling each other. The contact forces, that is muscular forces, friction and normal force. What is muscular force? Force exerted by muscle of the body. It enables us to push, pull, lift, carry objects. This force requires direct contact between the muscles and the object being acted upon. Let's take an example of running, walking or writing. In all these things, we involve our muscles. All these works are muscular force. Next thing is friction, a contact force that opposes the relative motion between two surfaces in contact. Friction acts in the opposite direction of motion and depends on the nature and roughness of the surface. Then the next thing, that is normal force, a support force exerted perpendicular to the surface of contact. When an object rests on a surface, the surface pushes back on the object with a normal force equal and opposite to the object's weight. That means if a book resting on a table, it exerts a normal force on the surface of table. Okay. Next thing is non-contact force, that is gravitational force, an attractive force that acts between any two objects with mass. It pulls objects towards each other and it is responsible for keeping us on the ground and planets in orbits around the sun. We can take an example of falling down any leaves or any fruits. Because gravitational force pulls the leaves and fruits towards the ground. So they are falling down towards the ground. Magnetic force. The force of attraction or repulsion between magnets or magnetic materials like poles repel each other while unlike poles attract, and this force acts without any physical contact between objects. If we take two types of magnets and we contact the one's north pole and another south pole, they are attracting each other because there is a magnetic force exerted between them. Then the electrostatic force, the force of attraction or repulsion between electrically charged objects like charges repel and unlike charges attract. It acts at a distance without the object needing to touch each other. So basically, electrostatic force is a force that is happen due to exchange of positive and negative particles. Because positive and negative particles are attract each other and they exerted a force, that is electrostatic force. The next thing is force as a vector quantity. A force has both magnitude and direction, making it a vector quantity. Vector arrows are used to represent forces. The length of the arrow shows the magnitude and the arrowhead shows the direction. Magnitude, that is how strong the force is. It is measured in Newton. Direction, the way of the force is applied, that is up, down, left and right. Vector arrows, drawn on diagrams to show forces acting on an object. Multiple forces on an object can be represented multiple arrows. So basically, the forces which has a particular direction called as a vector quantity. If we running, if you are walking, if a bird flying, if a cricket ball deflecting, it all have a particular direction. So all these are belongs to the vector quantity. Balanced and unbalanced forces. When forces act on an object, their combined effect determines whether the object moves, stays still or changes direction. Understanding balanced and imbalanced forces helps explain everyday motion and rest. Balanced forces, equal forces acting in opposite direction. The object remains at rest or continues at constant speed. Example, a book resting on a table. Unbalanced forces, unequal forces cause a change in motion, speed or direction. The object accelerates or decelerates. Example, pushing a box across the floor. Tug of war, both team pulls equally. The rope does not move, net force 0. No change in motion occurs in either direction. Tug of war, unbalanced. One team pulls harder. The rope moves towards them. Net force is not equal to 0. Motion changes in the direction of the greater force. Net force and its effects. Net force is the overall force acting on an object when all individual forces are combined. It determines whether an object will remain at rest, speed up, slow down, or change direction. Understanding net force helps us predict how objects behave under multiple roles. Under multiple forces. One, net force, sum of all forces. When multiple forces act on an object, the net force is their vector sum considering both magnitude and direction. If net force not equal to 0, the object accelerates, its speed up, slows down or changes direction depending on the direction of the net force applied. Number 3, if net force is 0, the object remains at rest or continues moving at constant speed, a state known as equilibrium where all forces are balanced out. Friction, an important force. Friction is a force that opposes the relative motion between two surfaces in contact. It acts in the direction opposite to the motion of an object and plays a vital role in our everyday activities, from walking to writing to driving. What is static friction? The friction that acts on an object at rest, preventing it from moving when a force is applied. It is the strongest type of friction. That means if we put a book on the table and it is in resting mode, it is called as static friction. Sliding friction, the friction that acts when an object slides over a surface. It is weaker than static friction. Example, a book sliding across the table. Rolling friction, the friction that acts when an object rolls over a surface. It is weakest type. Example, wheels rolling on a road making movement easier. Advantages and disadvantages of friction. Friction is a force that opposes motion between surfaces in contact. While it can be a nuisance in some situations, friction is also essential for many everyday activities. Understanding both its helpful and harmful effects helps us manage it effectively. Helps in walking and running by providing grip between feet and ground, preventing slipping. Causes wear and tear on machine parts, tires, and soles, reducing their lifespan over time. Enables vehicles to brake and steer safely. Tires grip the road due to friction between surface. It wastes energy as heat in engines and machines, reducing efficiency and increase fuel consumption. Methods to increase and reduce friction. Friction can be controlled depending on whether we need more grip or smoother movement. Understanding how to increase or reduce friction helps us design better tools, vehicles, and surfaces for everyday use. Rough surfaces using rough or textured surface increase friction. Example, groove tires, rubber soles on shoes for better grip. Applying brakes, pressing brake pads against wheels increases friction to slow down or stop vehicles safely. Lubricants, that is oil, grease, or water between surface, reduce its friction. Example, engine oil in machines, oiling bicycle chains. Ball bearings and smooth surface, that is ball bearings, convert slide friction to rolling friction. Polished surface also reduce friction significantly. Next thing is, what is pressure? Pressure is defined as the force per area. Pressure is the force applied per unit area on a surface. When the sum force is applied over a small area, it creates high pressure. Over a larger area, the sum force creates lower pressure. Example, a sharp needle exerts much more pressure than a flat surface even with the same force applied. If we take an example of a knife and apple, the sharp side of a knife cut the fruits easily, but the broad side did not cut the fruit easily. Pressure in liquids, gases, and atmosphere. Pressure is the force applied per unit area. Fluids and gases exert pressure in all directions. The atmosphere surrounding Earth also exerts significant pressure on all objects and surfaces due to weight of air above them. Pressure in liquids. Liquids exert pressure in all directions, upward, downward, and sideways. Pressure increases with depth. Deeper water, greater pressure. Pressure in gases. Gases also exert pressure in all directions. Air in a balloon pushes outward equally on all sides. Gas pressure depends on temperature and volume. Atmospheric pressure, the weight of air above us exerts atmospheric pressure. Example, suction cups, drinking through a straw, weather changes. Formula, pressure equal to force per area, smaller area, greater pressure. Example, sharp needle pierces easily, flat surface distributes force over large area. Real world application and summary. Forces in daily life, opening door uses muscular force, car brakes use friction in stop motion, parachutes use air resistance to slow descents safely. Pressure in practice, high heels exert high pressure on small area, sharp knife blades cut easily due to reduced surface area, syringe use pressure to inject fluids. Key summary, force is a push or pull, friction opposes motion, pressure force per area, balance force cause no motion change, unbalance force do. Any questions? If you have any doubt, then you can ask me in the comment section. So it's all about the forces and its uses. Let's end the class here. Thank you.